Hello, everybody. In this video, we're going to be going through Activity 313, Commercial Wall Systems. Now, we've talked about wall systems before. Previously in Unit 2, these were for residential purposes, and so you're going to end up seeing some of the differences between commercial wall systems. Obviously, these are going to be different from residential walls due to scale, load requirements, and also material performance. One of the other big things, one of the big ideas that's also very, very important, commercial wall systems are critical to not only just the structural integrity of the building, but also the building aesthetics. A lot of the times people think instantly, oh yeah, it's, just entirely structural integrity. That's the only thing that matters. It is very, very important, of course, but also included in that is also the building aesthetics. So be keeping that in mind. In terms of commercial wall systems, we can break these down into two main categories. Now, those two main categories are load-bearing walls, which these are going to be walls that can support floors above it, also roofs, and other structural elements. So it supports not only its own weight, but also the weight of elements above it. Now, non-load-bearing walls, those are going to be walls that support only their own weight. And so this is typically like for partitions in buildings, right? So we also do have a little preview here of the systems that we will be covering. And so in the ETEXT activity, you're going to actually choose between these wall systems here, which wall you're going to use for the wall on column line 3 of our Keystone library. So this is just what we went over just then. So here's some of these materials we can end up using for load-bearing walls. Please do keep in mind, once again, load-bearing walls, they carry vertical loads in addition to their own weight. Now, the note that I want to make for this is we often use these for 3 stories or less, and it may be pretty close to what residential construction ends up looking like, especially right here with the wood frame system that we have there as well. So other common commercial wall materials also include cast-in-place concrete, tilt-up concrete, as well as concrete masonry units. And so as you can see, all of these involve concrete. Now, when we are using concrete, it is very, very important that we are able to get the correct ratios of this. I actually worked 2 summers as a civil engineering technician. I was doing quality control and quality assurance. And what I would do is I would ensure that there's correct ratios of the concrete that's being used. For instance, as you can see, there's 6% air there. There's also 16% water. A lot of the times people that are on construction, they like to increase the amount of water that is used. That is cool how we just have the fireworks, but they'll try to increase the amount of water that is used because then concrete is a whole lot more fluid, right? It's easier to move around. It's easier to work with. But what ends up happening is that can have an impact on the overall strength of the concrete. It can also cause it to crack a lot. Also, if there's too much air in the concrete, it's going to have all these air bubbles in the concrete there. And so that's going to also reduce the strength of the concrete as well, right? And do keep in mind, concrete does have a very great strength in terms of compression. Tension, however, remember that is where it is pretty poor. And so that's why we use that reinforcement bar to increase the tensile strength. But the other advantage is it's very durable, right? It's also very fire resistant, also pest resistant, rot and rust resistance, low maintenance. It's also very energy efficient because the thermal mass that concrete has is able to store that heat energy. So there's many, many advantages of concrete. Now, green concrete, this is how you can end up getting LEED credits. And so LEED credits, very nice to end up having, right? It's basically you can brag about how your building is pretty green. So if you end up getting concrete within a 100-mile radius of the project site, you can end up getting LEED credits for that. If you also use these additives in here, fly ash, slag, and also recycled aggregate, you can end up getting LEED credit for that. You also have improved energy efficiency by taking advantage of the thermal mass of concrete, as we were just saying. Then you can go through the rest here to see that as well. But we have also cast-in-place concrete. And so what is cast-in-place concrete? And this is actually the first one that we're starting off with. Yeah, so cast-in-place concrete, this is the idea that we're going to end up bringing in these forms, right, or these molds. And then what we're going to do is we're going to pour the concrete in there after we have the reinforcement in there as well, right? And then we're going to pour this in. Those forms, we can then end up later taking off, or in some cases, they actually have it where you keep the forms in there and they kind of act as a form of insulation. But just as we were saying, tensile strength of concrete, pretty poor, right? Compression strength of concrete, very good, but the tensile strength is pretty bad. And so that's why we use that reinforcement bar. And so you can see here, there's the rebar. So this is just an example of cast-in-place concrete. So sometimes this rigid insulation that we have is actually the form as well for that concrete. So it kind of has that dual purpose. But then what we'll end up doing is we'll have the 1-inch minimum airspace between our brick and the actual rigid insulation there. Then we'll end up having the bricks here. And they have this whole breakdown of that. So just some examples of cast-in-place concrete. Burj Khalifa, very, very popular building, right? And so they use cast-in-place concrete for that. So just as we were saying here, sometimes that insulating form foam is going to actually serve a dual purpose as also being the concrete forms for whatever we actually pour in that concrete as well. So pretty nice. Tilt-up concrete. This is during my time as a civil engineer technician. For those 2 summers, I ended up actually seeing a school being built. Really, really cool. They ended up using a tilt-up concrete wall. And so what they end up doing for that is they actually pour it horizontally on the site. They have a form that they actually put that in. And so for the case of the school that I was working on, I ended up seeing they ended up bringing in all the concrete, right? They also put in some color additives to this, and they actually had it where that form looked like brick in a certain part. And so it had the form of bricks, and then they ended up adding in some red into that concrete too, so that at the end, it actually looked like actual bricks. But then what they'll end up doing is after they pour that horizontally, they'll end up using a crane to actually lift that up in place. And then, of course, they'll anchor that using rebar connection points. So as you can see, variety of amounts of shapes that we can end up creating with this. So they actually have a curved surface there. Here's an example too of also the brick that they end up using for those forms that looks like pretty realistic, right? But it is just all concrete. So this is the typical tilt-up concrete wall section. So as you can see here, we have these connection points that we could end up using. Most of the time, we'll use some epoxy to actually connect those points in there. Here's some other examples as well of tilt-up concrete or tilt-up construction. So pretty cool examples there. So CMU, if you look around our campus at our school, you'll end up seeing a whole lot of these concrete masonry units. And so what they'll end up doing, the concrete is cast into these hollow blocks here. And so we'll stack those. We'll also use grout to basically connect those. And then we'll use those the steel reinforcement bars. We'll send those down in there, and then we'll pour concrete in there as well. So that improves not only the tensile strength, but also the bending strength of this as well. So here's just some examples of masonry walls. And in terms of non-load bearing walls, so we're moving on to that now. Just as we were saying, it's not going to support any weight above it. It's only supporting its own weight. And so we're going to use this just to partition walls to separate interior spaces, right? Also to protect us from elements as well. If we end up using like a glass non-load bearing wall, that's called a curtain wall. It's just going to protect us from the elements, right? And so here's some of those common materials you can end up using for that. Now, these are curtain walls here, as you can see. Very, very modern look, very sleek look. This is an option for you for your Keystone library to add it on column line 3 there. And so it is a non-load bearing wall, just as you can imagine, right? This is glass here and some glass. If it's put under load, it is going to end up breaking. But then we also have metal as well. So they'll have like this metal little frame in there. So it provides visual appeal. Also, it's going to end up saving you energy, right? Because during daytime, you can use that as a lighting source. And then, of course, we're going to use that as protection from the elements. And so in this video, we go through the commercial wall systems. We talked about those 2 main types. We have load-bearing walls, which are going to be walls that are going to be supporting not only the weight of themselves, but also the weight of elements above it. Then we also talked about non-load-bearing walls, which are just going to be used to protect from the elements. And then also, it's only going to be able to carry its own weight. But anyways, in the next part of this video, I'm going to be going through what we're going to be doing for the actual ETEXT. So stay around, check that out, everybody. This is activity 313. And so we're going to be talking about commercial wall systems in this activity. Some tips for you all. Highly suggest make sure that you're always checking out these resources. Make sure that you download this presentation as well. We are going to go through this in class, but it's good to have that to reference. There's also the commercial wall systems green presentation as well that you want to download. In terms of our procedure, so we went through this in class, right? This presentation. You want to make sure that you're going through this and understanding all this background information. They're talking about how we're going to end up adding on the second floor here. And then they are wanting us to determine on column line 3. And if you end up looking at that, they'll give you the actual definition for column there. But on column line 3, they're going to be adding in the new wall. And so we went through these different types of wall systems that you can end up using for commercial walls. They're wanting to know what wall are you going to choose to put here. And so if we actually bring up this presentation here, so this is that downloaded presentation, you can end up seeing this a whole lot better. And so this is the 3D view of the actual library itself. We have the second floor that's added on. And what we want to know is that column line 3, which is right here, it's going to be the wall that's on here. We want to know what type of wall are we going to end up using. So this is just the north elevation view here too. And then if we go to this actual 2D view, you can end up seeing this. So this is column line 3 here. And so this is the wall. That's what we want to know. What are we going to end up adding on to that? What are we going to choose? So they also have this for the framing system as well. So framing planner, you can end up seeing all those specifications. We are going to use that later on. This is also the roof framing that we use later on. And then they also have the site plan, which would be good for you to take a look at that. But basically, you're going to be going through this. You're going to be researching each of those wall systems that we talked in our presentation. And you've got to come up with what wall you're going to end up using on that column line 3 on the second floor. And then you need to tell me why. You also want to make sure that you're creating the sketch of each of the wall systems, and you label the components as well. So that would be the exterior finish, what you're going to end up using for that. Insulation, so what's the R value of that insulation, and then also the interior finish as well. And then you also want to give the specifications such as the materials, the thickness of each component, and also that type of insulation, just as we talked about. Also give us at least one advantage and one disadvantage of each system for use in this application of the library. And so if you go through here, you can end up finding some other information about those that kind of summarize what we talked about in the presentation notes. And then down here, there's the curtain wall, which this is a very, very popular use for that wall that's on column line 3. Looks pretty modern. I really like the curtain wall myself personally too. But you're going to select that wall type, and then what we're going to do is we're going to actually add it to our Keystone library in Revit. All right. So note the other thing that is a turn-in for this, we do want to have that section view in the architectural software as well. So we've talked about that. We did that with a shed project, right? We also did that for our affordable home project. And so now we're going to be using that again for our commercial building here, the Keystone library renovation. But anyways, that is the basic rundown here of activity 313.